Alright guys, today we are going to talk about a brand new type of function called a logarithm. So before we get into what a logarithm actually is, let's pull up some prior knowledge. So we're going to solve some equations. The first equation that we're going to solve is x minus 3 equals 7. Now, this is a fairly simple equation. If I asked you to figure out how to undo subtract 3, which is what we do when we solve an equation, hopefully you would tell me that we would add 3 to both sides, leaving me with x equals 10. 10 minus 3 is 7. Likewise, if I had an equation like x cubed equals 27, if I asked you to undo the operation here, to undo a cube, we would use a cube root. And we would do this to both sides. The cubed root would wipe out the cube, and we'd be left with x equals, the cubed root of 27 is 3. What if I had the square root of x? Equals 5. Again, we know this is a square root, so to undo a square root, we would need a square. This operation would undo the square root, leaving us with x equals 25. Now, in all of these cases, we had an operation that would undo the previous operation. Those are called inverses. Well, what if I had 2 to the x equals 8? Well, there's no operation. I can't take the x root. That's not going to help me. I have to know what the power is. So at this moment, we don't really have an operation to be able to undo the x power. But we will now. Okay, so this is what the problem that mathematicians came into, is they couldn't undo that power. And so what we did is we figured out what's called a logarithm. Now, this x to the power, this 2 to the x equals 8, that's actually, that operation is called exponentiation. Exponentiation. And that just means that we have a base to a power of something unknown. Now, sometimes it's pretty easy to figure out what the answer is. So like in this case, 2 to what power equals 8? Well, 2 to the third equals 8. But what if we had 2 to the x equals 7? There's no power that's whole that would equal 7 if we have a base 2. But sometimes we want to know what that answer is. It's going to be 1 point something that's close to 2, but what is it exactly? So in order to figure this out, we ask ourselves, to what exponent would you raise the base 2 to get 8? And that answer is called a logarithm. Okay, so we are going to formally define a logarithm. So the logarithm base b of x is defined as y equals log. There's a little bitty base, so a little b here at the bottom, it's called a subscript. And then x is the same size as the y in the log. So y equals log base b of x if and only if b to the y power equals x. Now this only works if your base is greater than 0 and not 1, and if your x is greater than 0. So b is the base. Okay, so b here is the base. The x is the answer or the argument. The y is the exponent. Okay, so some things to keep track of these. Again, these are just two different notations. We have exponential form and we have logarithmic form. So one thing that might help you is to remember that the log equals the exponent. The log equals the exponent. Okay, so here the y and the y's, those are the exponents. The y's, so the log always will equal the exponent when we're trying to figure these out. Okay, so a logarithmic function is going to be in the form y equals log base b. Again, that b is called a subscript. It's usually below x. This is the inverse operation of the exponential function y equals b to the x. Now remember, we talked about y equals b to the x, that exponential function being 1 to 1, and it has an inverse. This is now its inverse, okay? So tomorrow we'll look at graphing these, but for right now we're just going to figure out what they mean, okay? So if we have something like 2 to the 4th equals 16, this means that if we want the logarithmic form, we say log base 2 Notice that we have the same base. Okay, so the way we read it, log base 2, 2 to the 4th. Okay, so log base 2 of the answer, so of 16, the answer is the argument, equals the exponent 4. Both of these equations describe the same relationship between the numbers 2, 4, and 16. What's different is that the exponential form gives us the answer. Okay, it says the base raised to an exponent equals the result or the answer. But when we look at a logarithmic form, it shows the log of the result with the given base equals the exponent. So it's the same relationship, just written in different forms, okay? So the very first thing we're going to do is we're going to work at converting between these notations. So on number 1, I'm going to have log base 4 of 16 equals 2. Okay, remember everything is in line. Notice log, 16, and 2 are all on the same line, and the 4 is below that. Okay? Oops. So we're going to rewrite this in exponential form. So the first thing we're going to do is we're going to write down the base. The base is the same base as the log base. The base is log base 4. So the base is 4 right there, log base 4. The exponent is what the log equals. Log equals exponent, so 4 to the 2nd. And this is going to equal 16. So 4 squared equals 16. That is a true equation. Both of those are. The difference is the logarithm gives us the exponent. It equals the exponent. And the exponential form equals the answer, the argument, 16. Okay, I want you to try to write number 2 into exponential form. So log base 1/2 of 32 equals -5. So take a second, pause the video, and try this problem for me. Okay, so when we go to write this, remember the base is the log base. So this base is 1/2. We're going to use parentheses because the power is going on the entire base. The exponent is -5. The log equals the exponent, and the answer is 32. The argument is 32. So this right here would be our form. All right, let's try one that doesn't have numbers, because maybe you were able to figure out where things went based on the numbers. What if I had log base A of B equals C? See if you can figure that one out. All right, hopefully you're ready for the answer. The base would be A, log base A. The exponent is C, that's what it equals. And B is the answer. A to the C power equals B. Okay, so hopefully you got that one right. If you did, give yourself a little smiley face. Okay, if you didn't get it right, maybe give yourself a little frowny face or star it. Make sure you go back and look at that one, okay? All right, now we're going to go the other way. So that was exponential form. Now we're going to go into logarithmic form. So on number 4, we're going to have 15 to the 3rd power equals 3,375. So the first thing we're going to do is we're going to write the word log because we need a logarithm. The log base is the same base as the exponent base. So the base here is 15. So log base 15 of the answer. The answer is 3,375. And this is going to equal the exponent 3. Okay, so I want you all to try number 5. 4 to the 1/2 equals 2. So again, pause the video and try this one, please. All right, hopefully you're ready for your answer. The base, we'd have log base 4 of 2 equals 1/2. And you do need to get used to the wording. Log base 4 of 2 equals 1/2. And there we have it. So again, if you got that one right, give yourself a little smiley face. If you didn't get it right, maybe star it or give yourself a little frowny face so you can go back and look at it. Okay? All right, again, let's try one without numbers. So let's try 7 to the p power equals m. So go ahead and pause the video and try this one, please. All right, so this one here would be log base 7 of m equals p. Okay, so again, if you got that one right, give yourself a little smiley face so I know you got it. If not, star it so that you know to go back and look at it. Again, the thing to keep in mind is the base is the base. It's the same in both. And the log equals the exponent. Okay, as long as you know the logarithm equals the exponent, you usually can figure these out. Okay, so that's the end of this first video.